9th Standard ICSE Chemistry Chapter 2 Chemical Changes and Reactions Part A Introduction. Here we have definitions of chemical change, a chemical reaction and a chemical bond. A chemical change is not necessarily a permanent change because it may be reversible, but it does involve formation of new substances with new properties. Old bonds are broken and new bonds are made. That's life. A chemical bond is the force that holds the atoms of a molecule together as in a compound. Now, chemical reactions can happen by any of the following methods. First of all, mixing, where the substances get very close to each other. Examples are given. First example, mark it as read, which means that it's not very important, but I can't cancel it. Lead nitrate plus potassium iodide gives potassium nitrate plus lead iodide. Notice that the white substance plus white substance gives you a yellow substance. So that's the observation. Potassium nitrate is white. So this reaction, when you learn it and when you write it, make sure it is balanced. The words like S are not important, but you need to remember that they are in solid state. Another example of solution form. Example 1, not important. Example 2, sodium chloride plus silver nitrate, aqueous, mentioning aqueous is necessary, gives you silver chloride plus sodium nitrate. This is a double decomposition reaction or double displacement reaction. It's a repeated reaction, so whenever you add a nitrate to any chloride, you will get a white PPT. That's a test for chloride anion, which you'll study in the future. Some reactions require heat, so whenever a carbonate is heated, oxide plus carbon dioxide is released. There are some exceptions to this as well. Lead nitrate, whenever it is heated, again a metallic oxide plus nitrogen dioxide plus oxygen is released. We will study decomposition of carbonates and nitrates in detail in part B. Some interesting observations here. Copper oxide is black and carbon dioxide is a gas which is colorless. It turns lime water milky but has no effect on acidified potassium permanganate solution. Lead oxide is reddish yellow when hot and yellow when cold. Nitrogen dioxide is a reddish brown vapor which turns acidified ferrous sulfate from green to brown. Oxygen rekindles a glowing splinter. All these observations are not mentioned in this chapter in detail, but it will be a part of your syllabus at the end of the year when the whole book will come for the final exam. So I'm just making you aware of these facts. Some reactions require light, for example photosynthesis, and even combination of hydrogen and chlorine to give you hydrogen chloride gas. So yeah, I mentioned gas, otherwise one may assume it's an acid, hydrochloric acid. So that reaction also requires sunlight, but direct sunlight would make it explosive, so use diffuse sunlight here. The third example, mark it as read. Next example is about sunlight falling on silver nitrate. It decomposes completely to give you a silvery metal, a reddish brown gas, and a gas which rekindles a glowing splinter. Even hydrogen peroxide decomposes to give you water plus oxygen. Hydrogen peroxide, by the way, is poisonous for us. Electricity can also bring about some reactions. For example, when you pass electricity through acidulated water, it splits into hydrogen gas and oxygen gas. Acidulated because pure water is a poor conductor of electricity. So we have to add a few drops of, say, dilute sulfuric acid to make it a good conductor. Similarly, if I take molten NaCl, and molten means fused, no water is involved here, and I pass electricity through it, it will be split into sodium and chlorine. Metal at the cathode and chlorine at the anode. More about that in 10th standard. Pressure. Pressure can also help to bring about a chemical reaction. Example number 1, just ignore it or just read it. Example number 2, this is called the Haber's process. This reaction will be repeated so many times in this entire book. Nitrogen plus hydrogen gives ammonia gas, but there are 4 conditions required. The pressure should be more than 200 atmosphere. The temperature should be 450 to 500 degrees Celsius. A catalyst is used, which is finely divided iron. And to increase the efficiency of the catalyst, we use a promoter called molybdenum. A catalyst simply increases or decreases the rate of reaction. In this case, it increases, of course. But there are some negative catalysts also, like alcohol is a negative catalyst for us as well as for oxidation of chloroform. Phosphoric acid is another example. Surprisingly, even sound can bring about some reaction. For example, acetylene, also called as ethine, it breaks down into carbon and hydrogen if we yell at it very loudly. But I'm sure you don't break down if someone yells at you. Example number 1 of a catalytic reaction is potassium chlorate, and the presence of manganese dioxide at 300 degrees Celsius splits into potassium chloride plus oxygen. The catalyst remains as it is at the end. It doesn't get affected. Similarly, we have a reaction in which ammonia gets oxidized to give you nitrogen monoxide and steam is produced. Platinum is the catalyst and 800 degrees Celsius. You have to remember the temperatures as well. This decomposition reaction of hydrogen peroxide was brought about by sunlight. We can accomplish the same thing by using a catalyst called manganese dioxide, which is black in color, by the way. Even in digestion processes, the enzymes used are actually biocatalysts. They break down a food. For example, saliva has a catalyst, an enzyme rather, called amylase, which breaks down the starch into maltose, which is sweet to taste. That's why if you chew your food for too long, you get a sweet taste. Now, some characteristics of reactions are that often a gas is evolved. For example, this is a displacement reaction. Zinc is above hydrogen in the activity series. It is more reactive, so it will displace hydrogen. Sulfate, who was with hydrogen earlier, will dump hydrogen and go with zinc, and poor hydrogen is left alone. It's a gas. It creates effervescence, that is bubbling, foaming. And the test for hydrogen is that it burns with a pop sound. Similarly, if I add any acid to a carbonate, like marble chips or something, carbon dioxide gas is released. Change of color is also noticed in many reactions. For example, here, iron is more reactive than copper, so a displacement reaction takes place. Observation, blue solution becomes green solution, and copper is left alone. At the bottom of the beaker, we see it as a red deposit, a red residue. Another example is conch sulfuric acid reacting with copper to give you sulfur dioxide gas. Now, copper is below hydrogen in the activity series, so typically acids should not be able to react with copper, silver, etc. But since it is conch, here it acts like an oxidizing agent and a reaction does take place. Observation, a blue solution is formed. Now, formation of a precipitate. Some reactions, this is a double decomposition reaction. It produces two salts, one is soluble aqueous, but one is a PPT. It settles at the bottom of the beaker. This is a repetition again. Chloride means that we'll get a white PPT. Extra information, it is soluble in ammonium hydroxide but insoluble in dilute nitric acid. How is it relevant? Well, it will be in a chapter called Practical Chemistry, chapter number 9, and in 10th standard. Another reaction, here you have again double decomposition reaction. When sodium hydroxide reacts with the ferrous salt, you get a dirty green PPT. That's an identity of ferrous salts. If it was a reddish brown PPT, it would have been a ferric salt. Change of state. Here you see two gases are reacting, but we get a solid, a sublimatory solid. Dense white fumes will also be formed here. Here again, a solid is reacting with another solid to give you a liquid. So we need to remember their states, but no need to write it while practicing the equations.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.